Just another counting problem using our method we just have now talked about. Let's talk about license plates. Okay, how many license plates can be made using 3 letters followed by 3 digits? So we've got license plates, and pretty common one is have 3 letters and then three digits. How many possible ones are there of those? All right, well, what are we going to do? Obviously, we're not going to count them all up one by one. We're going to use our blanks, right? How many blanks will this one entail? We have 6 blanks, 1 for each letter, 1 for each blank, 1 for each digit. 3 letters, 3 digits. All right. First letter, how many possible? A through Z, A, B, C. How many is that? 26. 26 letters in the alphabet. All right. How many for the second letter? Can we use repetition? Doesn't say we can't, right? So we can. We can use repetition. So whatever one here can be used again here. So how many letters? Still 26. Yeah. Still 26. Yeah. And then 26 for the third letter. Yeah, you can repeat. So you have all 26 letters in each case. Now what about the digits? First digit right here. 3 letters, so this is the first digit. Usually we say the first digit can't be 0. But in a license plate, can the first digit be 0? Yeah. In a license plate, you can have the first digit be 0. So how many digits does that make for the first blank here? That'd be 10. And then the second blank, 10 is still, and then still 10. Okay. All right. So, what do we do with that? Multiply together. So that is a bunch, yeah. It's 676 something, isn't it? 26 times 26 times 26 times 10, 10, 10, which is 1,000. Nope, I was wrong. 17,576,000. You can do a lot of license plates. That would cover Missouri pretty well, wouldn't it? Okay. All right. So one more of those, and then we'll move on to our next. All right. So how many license plates with 2 digits followed by, we're going to switch it up, 2 digits followed by 4 letters have no repetitions? How many? Okay. How many license plates with 2 digits followed by 2 letters are there with no repetitions? So unlike before, now we have the restriction that, yeah, there's not going to be repeating of anything. Okay, so we've got 2 digits, then 4 letters. 2 digits first. So here's my digits. And again, in license plates, you can use 0 as the first digit. So how many digits for the first blank? There'll be 10. Everybody okay with me on that? You got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the possibilities for the first blank. What about the second blank? There's no repetitions, so it goes down to 9, doesn't it? Whatever I use here, I can't use again here, so that's only 9 possibilities. Okay? Now I'm to a letter. 26 letters, so the first letter could be 26 of the possible ones. What about the second letter? No repetitions, so that means we go down by 1. And then down by 1 again, because you can't repeat that one. Then you can't repeat that one, so it's down to 23. 10, 9, 26, 25, 24, 23. So you can see how that works. All right? So that's still a lot. 32, 292. Yeah. Questions or concern?
If there's more restrictions, how come the probability is higher than 100?
Okay, yeah. The reason is I've got more letters. The reason this one's higher than this one, yeah. Yeah, because if we had no repetitions here, of course you'd have fewer, but we have more letters here, so that's why it's more there. Okay, got another one for you. And this is one where I may talk about a couple of new buttons on your calculator, which you may have not have used before. Maybe you have, maybe you haven't. Probably most of you have. Okay, let's say we have this. In a race with 6 contestants, how many ways can the finish occur? Race, it's got 6 contestants. How many ways can our finish occur? No ties, so we've got first through 6th place, basically, right? So we've got one blank for each place. First, second, third, fourth, fifth, and 6th place. Everybody's going to place. All right, so how many ways can first place occur? Any of the 6 could possibly win first place if we choose to do first place first. Makes sense, right? What about second place now, though? How many possible is it? Why is it only 5? You can't finish first and second, so we can't have repetitions. So again, we're down to no repetitions, so this number goes down to 5. And then third place? It would be 4. Yeah, you can't have repetitions again, so yeah, you're losing one each time, aren't you? 4, and then 3, and then 2, and then last would be 1. Multiply all those together, and you get about 720. Okay. Now, what I wanted to show you on this one is look on your calculator and see if you have this button right here. N with an exclamation point or X with an exclamation point. And if you don't see that, let me know. See it? Don't see it? All right. Look for a PRB button. You see a PRB button. If you don't see our PRB button, all right. So press the, huh? No. No, it's yours is right there. Right here. So hit your second or your shift button. All right, and when you find that, do 6 and then the N exclamation point or N whatever it is, hit that button. It might be. Yeah, if you have a PRB button, hit 6 and then the PRB button and then go over to the exclamation point. Right there.
Well, I didn't touch anything.
Okay. So
I just did the number and then the PRB.
Okay, so just arrow over to it.
Oh, okay.
And then equal.
Okay.
And then hit enter.
That's nice.
What do you get? Anybody else find it? Okay. So yeah, just hit 6 and then the exclamation point. Or yeah, if you have to do the second button. Yeah, you might have to put, if there's a if it's above the something. If you have trouble with it, just let me know. I'll help you figure it out.
So you're really getting in response.
Some of it just depends on the calculator you have. All right. But once you get that all figured out, what do you get if you do 6 and then the little factorial? What you're calculating is 6 exclamation point. What do you get? Should get that. Oh, okay. Where's your clear? Okay, 6 and then shift exclamation point. There you go. Now enter. Okay? Did you get it? Okay. So hit 6, shift. There you go. Okay. All right, what we found here is what's called 6 factorial. The little exclamation point is called the factorial button. And so what does 6 exclamation point mean? It means 6 times 5 times 4 times 3 times 1. I call it the countdown product. This 6 factorial starts at 6 and multiplies 6, 5, 4, 3, 2, 1 from 6 to 1. So it's a nice little short way of computing a countdown product like that. 6, 5, 4, 3, 2, 1. All right? So what do you get if you do 8 factorial? Is it 40,000 something? 40,320. Okay. Now what you've done there is you've calculated what? What product? Starting at 8, counting down to 1, right? Without actually having to multiply it, you have multiplied 8, 6, 7, 6, 5, 4, 3, 2, 1. Okay? So that's a nice way of evaluating such a thing. The countdown product is factorial. All right, so here's another problem. How many ways can 10 books be arranged on a shelf? How many ways can 10 books be arranged on a shelf? Well, we're going to arrange all 10 books, so there's 10 spots, one for each book. Okay? There's 10 ways to put the first book in, but once we get the first book put in, we don't put it in again, so that leaves us only 9. And then the next one we put in, we'll only have 8. What is this? Otherwise known as what? 10 factorial, isn't it? Yeah, 10 exclamation point is the number that we would get there. And that would get us $3,628,800. All right. So that's some nice little problems if we run into that countdown product that starts at a number and counts all the way down. Now, we hadn't encountered any of those previously, so they are kind of specialized problems. But anyway, if we get them, that's what we can do. That was too easy?